What we have learned is that the moon has picked up a new tag along in space. It is called, this asteroid is called 2025 PN7. It's officially been called a quasi-moon. It was discovered by the University of Hawaii, and we want to bring in Derek Buzasi. I hope I got your name right. Correct me if I got it wrong. Buzasi, who is a senior instructional professor in the Department of Astronomy and Astrophysics at the University of Chicago. Okay, so first thing on the list, make sure I got your name right. Was I close?
Oh, you were close. It's Buzasi. So if you pretend there's an H tucked in there, then you got it exactly.
Got it. Buzasi. Okay. Well, we thank you for your time today. This is really interesting. Is this the first time that the moon has had a companion like this? And what does it mean to be a quasi-moon? So similar to the moon, but not the moon.
Right. It's not the first time. And really there's two kinds of moons like this. There are these things that we call mini moons, which are actually sort of orbiting the Earth just like the moon and are captured by the Earth, and usually temporarily. They're all fairly small. And then there are these quasi-moons, and these are in orbits that are very like the Earth's orbit. So they're not really orbiting the Earth, but the Earth's gravity is kind of helping to shepherd them a little bit. You know, when you think about the orbit of something, you want to characterize it. How big is it? What is its shape? Is it circular? Or is it all stretched out? And how is it kind of tilted with respect to the Earth's orbit? And all of these quasi-moons, all of those parameters, you know, the shape, the size, the tilt, are close to but not exactly the same as the Earth's. And so they kind of tag along with us. Sometimes they're a little ahead, sometimes they're a little bit behind. So they're not really orbiting us, they're kind of following along with us. And what's keeping them in that area of space sort of near us is the Earth's gravity kind of shepherding them around a little bit.
Now, you said this is temporary. So how long will this tag along situation last?
Well, it's hard to tell exactly, but you know, we would guess in this case, as sort of an educated guess, is probably tens of years, so maybe 50, 60 years, something like that. So it's temporary, but it's, you know, a human lifespan basically, so it's not that temporary.
So walk me through, how does this happen, and really what is the purpose of this quasi-moon?
Well, purpose, I don't know. They really don't have a purpose. They just are. But they can come from different places. So they can come, for example, you imagine like a big asteroid hits the moon, which still happens from time to time. And then there's the material sprayed out from the moon, and that material can sometimes end up in orbit around the Earth, just like the moon is. And we've only had 4 of these little mini moons before, and one of those seemed to have that origin. This one looks like it's just a captured asteroid. So there are belts of asteroids around the sun, orbiting the sun just like planets. The biggest one is out between the orbit of Mars and Jupiter, and there are literally millions of them, all small rocks to sort of mini moon-sized things. And this looks like it's one of those that got captured. And we just guessed that based on you know, the velocity that it has and the kind of shape of the orbit that it has. It's more likely to have come from outside in the solar system than it is to be been captured from our moon.
I know we've been talking about size, and I want to put this into perspective and compare it to something that people can understand. So it's estimated to be only 18 by 36 meters wide, and they say that is about the height of a small building. So if we're talking about perhaps in the city of Chicago, that would typically be a 6 to 10 story apartment or condo building, maybe with a little retail space on the bottom, maybe even perhaps a rooftop or terrace on the very top of the building. Is it possible at some point, could something come along that is big enough to block out the moon or possibly even the sun?
Not likely. I mean, the moon is pretty, you know, is obviously quite large in the sky. You'd have to bring something in really, really close. I don't think you're likely to get something that's that big. And these things are small, which makes them hard to find, but we're getting so much better at finding them. And that's kind of why you're starting to hear these stories more and more. It's just that our ability to see them has improved a lot. If you go back 20 years, we would never have been able to see something this size. Now we can, and we're starting to detect them on a more and more regular basis. We have projects starting up that are going to map the whole sky in detail and depth, way beyond anything we've done before. And so they'll see even more of these things. So you can expect that there are more of these visitors. I'm sure they're there now. It's just that there are even smaller ones that we're not able to detect yet, but it's coming.
So when I first saw this and I was thinking about how did they see this? This must be some new innovative technology or something. I went to this one stanza within this that says this, which I find to be very interesting. The University of Hawaii team first spotted the object during a routine telescope survey earlier this year. What looked like a faint speck moving against the stars turned out to be following Earth's exact pace around the sun. Now, after weeks of observation, NASA then confirmed that the data was correct. Our planet had gained a temporary traveling partner. When we talk about telescopes and people looking, into our Earth, looking at all of these objects rotating, is this something that people or scientists are always looking for?
Sure, there are teams that are looking for this with great interest, not partly because it's scientifically interesting, but also in some cases these NEOs, these near Earth objects, are interesting in the sense that it would be bad if one of them hit us and we didn't know that it was coming, because even something the size of an apartment building, which compared to the Earth isn't very big, if it's moving at sort of tens of kilometers per second, tens of miles per second, which some of these objects are, and it strikes the Earth, that's a very big explosion and would be very bad. So there are programs underway to kind of try to map all of these and find them all, so we kind of know what's out there and whether stuff is going to come in to hit us. Now, I mean, for scale, to give you maybe a sense of how hard it is to do these things. So this one, which, as you said correctly, is like the size of a Chicago apartment building. It's about 100 million times fainter than the faintest star that you could see with just your eye, without a telescope. If you went to a really dark place, so not Chicago, if you sailed out onto Lake Michigan, or you went down into the depths of Iowa in the cornfields far away from anything, the faintest star you could see would be 100 million times brighter than this thing is. So it really is pushing our ability to find these very small, very faint objects.
It seems like as of lately, we've been talking about all these different discoveries, whether it's Earth or something involving Mars. Or why do you think we're talking about this so much more than before? Is it because of technology, or is it that more things are happening out there?
I mean, both, because the technology allows us to access the fact that more things are happening, right? I mean, you build a new kind of detector, a new, more sensitive detector. You build bigger telescopes. You look at parts of the electromagnetic spectrum that you couldn't really see well before, but now we have telescopes to look at, and that kind of opens things up. And then you start seeing things that you didn't expect. I mean, the saying is the sound of discovery isn't necessarily what you'd expect. It's someone looking at something going, that's weird, I wonder what that is. And we're getting a lot more of that because we have this level of sensitivity and this new technology all the time coming online. So I think a lot of it is technologically driven at this point. And sciences, I think astronomy is one, but all of them probably are like this. They go through phases, right? There's a phase where people are busy explaining what they found before, and then you sort of start to get a handle on it. And then there's a new set of observations which says, oh, here's some new stuff or things you hadn't thought of before. And then the people who do the theory go to work trying to explain what it is. And I think we're in a kind of data-rich environment now. So there's more and more of this information coming in, and we're going to see more and more of these kinds of discoveries. And then we have to take some time to explain what they are.
Since you've been involved in astronomy and astrophysics, what is one of the most exciting, compelling things that maybe you've ever seen?
Ooh, I mean, for me, I don't work specifically on these kinds of objects, but I work on exoplanets some of the time. So finding planets around other stars. And so for me, one of the more exciting things was back when the Kepler mission, NASA's Kepler mission, was launched and was early on in its operation. We found one of the first planets orbiting a binary star. So we found the two stars orbiting each other, and then we also found a planet orbiting that system. And that was kind of miraculous and exciting. It's always exciting to find a planet, but this is one that, sort of reminds you of Tatooine if you're a Star Wars fan. And so, it was kind of exciting to see the science fiction turning into science fact when you find something that looks just like what you saw as a kid in a movie.